Welcome to Statistics 1, Chapter 6, the binomial distribution, topic expectation, variance, and typical questions. Later in the video, I will work on a typical question in the S1 paper for binomial distribution. It will help you to understand how we can work out a question in the topic in the exam. So first, we will work on expectation and variance. Let's see, I have a random variable x as a binomial distribution n p. N is my total number of trials, and p is the probability that I will succeed. So for expectation, e x, this one expectation is also equal to the mean. The mean equal to, in this case, np. So why is np? If the probability that you will be success in an event or in a trial is p, but you do it n time. You have n number of trial, and the probability that you will succeed a trial is p. So the expectation that you will succeed in n trial will be n multiplied by p. Really easy to understand. The next one, we will work on the variance of x. Variance of x is equal to n multiplied by p multiplied by q. P is the probability of we can succeed in a trial, and q is the probability of failure for that trial. Because p and q are the only two possible outcomes of a trial, so we can have another formula for that. It's n multiplied by p multiplied by 1 minus p. Because p and q are up to 1. We all know that p and q are two possible outcomes for a trial, so the sum of the probability is always 1. So p plus q is equal to 1. And we know that the variance is the square of the denotation for variance is the square of a standard deviation. Now we will work out the standard deviation from the variance. We have the standard deviation is equal to square root of n multiplied by p multiplied by q, or square root of n multiplied by p multiplied by 1 minus p. Now we will take a look at the questions down here. There is a fault in a machine making microchip with the result that only 80% of those it produced work. A random sample of 8 microchips was made. By the machine is taken, find the expectation of normal microchip, the variance, and the standard deviation. First of all, we work on the expectation of normal chip, because the probability of normal chip is 80%, which is 0.8. Work on expectation of x. Expectation equal to 8 multiplied by 0.8, which is equal to 6.4. The next one, we will work on the variance. Variance x equal to 8 multiplied by 0.8, 1 minus 0.8, 0.8 equal to 8 multiplied by 0.8 multiplied by 0.2, which is equal to 1 to 0.28. The variance is the square of the standard deviation. The standard deviation would be equal to the square root of 1.28, which is equal to 1 0.13. So now is how we can solve a problem related to expectation, variance, and standard deviation. Sorry, here should be a C. Expectation. Now we will work on the example question. Extensive research has shown that 1% out of every 4 is allergic to a particular grass seed. A group of 10 university students volunteered to try out a new treatment. So first, find expectation of the numbers of allergic people in the group. First of all, question I small. Expectation, we know that is equal to n multiplied by p, which is equal to, in this case, number of students join the investigation is 20 students. The probability that a person is allergic to a particular grass seed, 1 out of 4, means that 1 divided by 4, 1 out of 4, which is 0.25. The probability that one person is allergic to a particular grass seed is 0.25. This one is equal to 5. Expectation, there are 5 people are expected to be allergic in this group. For the next question, what is the probability that exactly two people of the group are allergic? So the probability P of X equal to 2. Equal to, we have 20 students, 20 to 2 multiplied by, because we have the probabilities of being allergic is 0.25. If 2 students are allergic, so 0.25 to the power of 2 multiplied by, because the Q will calculate Q, which is equal to 1 minus P equal to 1 minus 0.25 equal to 0.75. 0.75. We have 20 students, 2 students is allergic, so we have 18 more students not allergic to the particular grass seed, which is equal to 0.0669. Now we work on the question B. What is the probability that more than 2 of the group are allergic? So we write down P, probability of X greater than 2. Because X is greater than 2, it can take up any values from 3, 4, 5, 6, up to 20s. And when we calculate them, it's really intensive and really hard to find the exact number. So I have a new way, a different way, which makes the outline easier. Equal to 1 minus probability that X is greater than or equal to 2. Why this one is correct? Because we have a total probability is 1. The probabilities of X greater than 2 is equal to the 1 minus probabilities of X smaller or equal to 2, because they both construct a total probability is 1. So now we'll go and find this one. This one is equal to P of X smaller or equal to 2, which is equal to P of 0, X equal to 0, plus P of X equal to 1, plus P of X equal to 2. Now, P of X equal to 0 means that none of them are allergic to this particular grass seed. So 20 of them are not allergic, so we have 0.25 to the powers of 20 plus. Now one of the 20 people are allergic, so from 20 we choose 1 to be allergic. 0.25 1 multiplied by 0.75 power 19, because 19 of them are not allergic. But 20 by this one, 20 C2 multiplied by 0.25, 2 multiplied by 0.75 to the power 18. So these are equal to 0.0912. This one is equal to 1 minus 0.0912 equal to 0.909, rather to 3 significant figure. So this one is our final values that we can get from the question. Final values. Answer. Now we'll take a look at the final question. How large a sample would be needed for the probabilities of it containing at least one allergic person to be greater than 99.9%? So the question is asking us to find n, because it says how large a sample would be needed. At first our n is 20, but now it requires new n. Now we'll solve it by step because this question looks quite abstract and hard to follow. First of all, let's solve the question. Let's say that it containing at least one person is allergic. So P of x is greater or equal to 1, at least one people, equal to 1 minus P of 0. Same method to think from this one. You can see that they are equal to these and this add up to 1. So we know that this 1 minus 0.75 to the power of n. Why? Because we are looking for the number n, this number of sample we want. So the probability that no one in the sample n is allergic, no one is allergic to the grass seed would be 0.75 to the power n. Now see, because we have the probabilities of this one is at, because they say this probability is greater than 99.9%, which is 1 minus 0.75 to the power n greater than 0.999. So simple math, 0.75 to the power n have to be smaller than 0.001. So from here, how can we find the value n? So we can use the logarithm, which you can learn in P2 and have a closer look in P3. Now we'll use the logarithm to solve this question. Logarithm. I have log of 0.75 to the power n greater than log of 0.001. Here, when we use the log, we change the position. At first, it is smaller, but the log of the smaller one will be greater. Next step, I will solve this mod and log 0.75 greater than log of 0.001. There is a simple rule in log, is that log of a to the power b equal to b log a. So now I can solve this one so that n, I will do it here, n would be greater than log of 0.001 over log of 0.75. We can use calculator to calculate this number. is greater than 24.01, because n is a integer, because it's a number of people that we would choose, because the question itself say that how large a sample would be needed. It means that we need to find the smallest number that can be suitable with this one, the final thing that we find here. Because n is number of people, so we would choose an integer, and the smallest integer which is greater than 24.01 is n equal to 25. So we need at least 25 people for the probabilities of it containing at least one allergic person to be greater than 99.9%. One little notice for you guys, even this one 24.01 is really close to 24, but we need to find the one which is appropriate and suitable for this condition. So the only one, because 24 is not greater than 24.01, so we need to take the value 25, the next one after that.